Hello everyone, welcome to my YouTube channel Sanha Academy. If you are new here, kindly subscribe and hit the notification bell for more informative videos. So you can see this icon, subscribe, and you can see this icon as a notification bell. So anytime we release a new video, you can be notified. In today's video, we are going to talk about the introduction to system programming. And here is the outline of the presentation, which are three. Number one is brief overview of system programming. The second one is definition of assembler. And the third one is types of assemblers and loaders. So these are the three items that are going to be covered in this video. Stay tuned. Before the brief overview of system programming, let me brush our knowledge. What is computer? The simple definition of computer is an electronic machine that can accept data as an input, process the data, and produce the result as an information, and it can store the results for future use. And also there are two constituents, or some scholars call it categories of computer system. We have hardware and software. Hardware is any physical component of a computer system that you can see and touch. This is hardware. What about software? Software is a set of instructions that tells a computer system how to perform a task. So if you look at our today's video is introduction to system programming. So the two categories or the two constituents of a computer system that we have, which is hardware and software. So if we narrowed it down to our today's lecture, which is system programming, so that system programming falls under system software, which is one of the types of two softwares that we have. There are two types of software: system software and application software. So let's begin to see the brief overview of system programming and see how we can compare between system programming and application programming, or system software and application software, because our today's video is solely for the system software, which is system programming. So system programming, or we call it systems programming, is the activity of programming system software. Activity of programming system software. So it's all about creating a system software. It's a system which is called system programming. And also system programming, in another concept, is it aims at producing software. It aims at producing software which provides services to computer hardware, such as disk defragmentation is a system software, and system programming has been used to develop disk defragmentation software. Operating system, also a system programming, has been used to develop an operating system. So all these softwares, these two examples of softwares that I just mentioned, helps the computer to instruct the hardware. I mean, they manages the hardware component of a computer system. So the primary distinguishing characteristics of system programming when compared to application programming is that application programming aims at producing software which provide services for a specific purpose. Example, word processor such as Microsoft Word, Notepad, WordPad, WordPro, and etc. Such as spreadsheets, such as Lotus 123, Microsoft Excel, and etc. Such as databases softwares like Microsoft Access, Oracle, and etc. Accounting packages, and many more. So any software that is being designed for a specific purpose is what we call application software. Like I mentioned earlier, that there are two types of software: system software and application software. Now, the primary distinguishing characteristics, that is the primary difference between system programming and application programming, is that application programming has been designed for a specific purpose. Just like for example, a WhatsApp. Can you use a WhatsApp application to design a poster? No, you cannot do that, because it is purposely designed for communication, sharing information between friends. It's a social media platform. And for example, for word processor, example Microsoft Word, can you use Microsoft Word to design a key holder? Or can you use Microsoft Word to see the weather, current weather for today? No, because Microsoft Word has been designed for typing text memo, writing a letter, handout, and etc. So you see, the application software has been designed or developed for a specific purpose, while system programming has been developed for creating a software that will manage the hardware component of a computer system. Let's see the difference between system software and application software, or we call it system programming and application programming. Here are 8 difference between the two types of the software. System software is designed to manage the resources of a computer hardware and software, while application software has been designed to fulfill the requirement of the user for performing a specific task, just like I mentioned in the previous slide. The second one is system software start running when the system is powered on and runs until the system is powered down. This is one of the activity of system software. While the application software starts when the user begins, that means, and it ends when the user stops it. This means if you launch a Microsoft Word or Access or any application software, then from that time you begin to use the software, and it will stop when you close that application software. But for the system software, once you power on your system, then your system software start running, and it cannot stop until you powered down your system. Number 3, the system software is a general purpose software, while application software is a specific purpose software. System software independently, which is number 4, but application software cannot run independently. So this one and this one, that is number 3 and number 4, depend on the number 2. Then number 5 is users never interact with system software as it functions in the background, because it functions in the background of your system. So there's no way user can interact with the system software, but user interact with application software while using specific applications. So any application software that you open, you are using it, that means you are interacting with the application software. A system software are independent of the application software, while application software needs system software to run. There is no way your application software can work without installing a system software. And debugging, that is correction, is very difficult in system software, while debugging is not too difficult compared to the system software and application software. So this is key difference between system software and application software, and our focus area is system software. These are the more difference of system and application software. Again, you can see the hardware components: CPU, RAM, disk, printer, And for the system software, you can see operating system and utilities manages all these hardware component. So once you have your hardware component, system software can help to manage the hardware component. Then application software can be able to be installed and used when the system software is installed in your computer. So these are some of the another key difference of system software and application software. Alright, this is all about the item number 1 of the presentation for today, which is an overview of system software. Then the second part is assembler. What is assembler? Most programming nowadays is done using so-called high-level languages such as Fortran, Basic, COBOL, Pascal, C, C++, Java, Scheme, Lisp, Ada, Python, and etc. So these are the high-level programming languages that we have. And the second one is these languages deliberately hide from a programmer many details concerning how his problem actually will be solved by the underlying computing machinery, because the programmer only knows the high-level programming languages, but he doesn't know what the machine can understand. I don't mean he doesn't know, but these languages hide some aspect that the programmer should know. Like, for example, the basic language. Some languages allow programmers to forget about the computer completely. Seriously? The language can express a computing problem with a few words of English plus formulas familiar from high school algebra. Example of the one of the problem example using basic language is, like, for example, if you are to compute 4 plus 5, definitely the answer is 5, right? So let's see with the basic programming language. This is the basic programming language of computing 4 plus 5. Let x is equals to 4, let y is equals to 5, let z or z is equals to x plus y, then print x, y, it will give you the z. That's the end of the program. And when you compute this one into basic programming language, it will give you the answer is 9. So this basic programming language is a high-level programming language. This is another example of a language, which is C. This is how you can compute 4 plus 5 in another language, which is C programming language. Then the key point is high-level languages let programmers focus attention on the problem to be solved. The previous programming language that I just mentioned, all of them are examples of high-level programming languages because they let programmers focus attention on the problem to be solved and not spend effort thinking about details of how a particular piece of electrical machinery is going to be carried out the pieces of a desired computation. This is the key point of high-level programming language, and the key benefit is their problem gets solved sooner because their program can be written faster, which is that is the high-level programming languages. So programmers don't have to know very much about how a digital computer actually works. So this is the key point of high-level programming language. But computer sciences do want to know how computers actually work and not only to write the programs, the high-level programming languages. So they can fix computers if they break. They should know how computers actually work so that they can be able to fix computers if they break, so that they can employ optimized algorithms, so that they can predict computer behavior, so that they can devise faster computers, so that they can build cheaper computers, and also they can pick one suited to a problem. So seriously, programmers shouldn't be limited to only high level programming language. They do also know how computers actually works. This is where low level languages appear. So if you know high level programming language, it's good for you to know the low level programming language, which is, we call it machine on language. That is machine language, the only language that a machine can understand, or that a computer can understand. So for understanding how computers work, we need familiarity with the computer's own language, which is called machine language. It is low level language which is very detailed. It is specific to a machine's architecture. It is a language spoken using voltages. Humans represent it with zeros and ones, which is binary numbers. So this is low level language. We discuss, or we talk about high level programming language, and mention some examples previously, which is limited for a programmer. And if a programmer really want to know more about the machine, how it works, a programmer should know a low level programming language, which is a machine language. So example of machine language for that computing of X and Y. So you see, this is the program for high level programming language using basic programming language, and you see how the high level programmer computed the program. But all this thing a machine cannot understand. It needs a translator that can help the machine to understand by converting this high level programming language into binary language, which is the only language that a machine can be able to understand. So these are the binary numbers that only a machine can understand. So here is what a program fragment looks like for computing z plus y. Oh, sorry, x plus y. It converts all the high level program into machine language. So what exactly software that helps in converting the high level into a low level language? We call them assemblers. So assembler is a translator that translates source instructions in symbolic language into target instruction in machine language on a one-to-one basic. So you see, so the source code, this is a high-level programming language, and assembler help in translating this high-level programming language into machine language. So after executing this program, the assembler assembly software will help in converting all these characters to a binary number so that the machine or the computer can be able to understand. So this is all about how an assembler can help in converting a high-level programming language into a low-level programming language. So let's also quickly brush our knowledge. How does a computer system works? How? A computer can accept data as an input. When you imputed a data like B, 10, ampersand, anything that you imputed from the keyboard, or whether a sound or anything, computer can accept that data. But before your computer can be able to produce the result, it has to undergo processing. So the assembler that I just mentioned before is also part of this processing, because it helps in translating the high-level programming language into low-level programming language, which the machine can be able to understand. Then after processing, then it will bring out the result, which is decoding and presenting the data to a user, and it will store the result for future use. This is just to brush our knowledge on how a computer system work. What are the types of assemblers that we have? There are primarily two types of assemblers which are listed below: one pass assembler and two pass or multipass assembler. We call it two pass or multipass assembler. These are the two main types of assemblers. This type of assembler converts the whole assembly code into machine code in one go, just one go. But for the two assembler, these types of assemblers first perform code processing and store the values in the opcode table, and the machine code is generated using these tables in the second step. So this is the difference between the one pass assembler and two pass. The one pass is just go on one go, just translate or convert the high level language into low level language or machine code. But two pass assembler has to perform a code processing. After processing the code, it will store the values in the opcode table, and then machine code is generated using these tables in the second step. These are some important terms for the pass 1 and pass 2, or one pass assembler or two pass assembler. So for the one pass assembler, opcode and symbol tables are defined, location counter record keeping, processes pseudo instructions. These are the some of the important part of one pass assembler. And the second one is it convert opcode into numeric opcode. Then the machine code generation according to the values of symbols and literals. Then these are some of the important terms again. Symbol table. What is symbol table? They keep track of the value of the programming language symbols and their related numeric values. This is the work of symbol table. Then what is opcode table that we just mentioned? They keep track of the value of mnemonics and their numeric equivalent. The location counter, it saves the address of the storage place for the current instruction. Thank you so much for listening. I hope this presentation is informative to you. So like I mentioned earlier, if you are new, kindly subscribe and hit the notification bell for more informative videos. Thank you so much. See you next time.